All right, guys, so what we're looking at here is an example from 2013 of a Taylor series, okay? And so let's just jump right in and take a look at what it says. And it doesn't give us much information. Usually Taylor series problems give us more information than this one. But this says the function f has a derivative of all orders at x equals 0. That just means the derivative exists forever. Let p sub n of x denote the nth degree Taylor polynomial for f about x equals 0. So basically, if I see p sub 2 of x, that means I have a second degree Taylor polynomial at 0. So it's like a Maclaurin polynomial, if you will. Or like p sub 4, that'd mean I need 4. So I'd have x to the 4th. That's all that means, okay? So this says it is known that f of 0 equals negative 4, and that p of 1/2 equals negative 3, show that f prime of 0 equals 2. Well, remember, when we build a Taylor series, we take our first term where the series is centered, so I take that negative 4, plus the derivative when I plug that in, so that's my first derivative, multiplied by x minus 0, in this case, to the first power over 1 factorial, so it's just 1. This is saying that that is equal to negative 3 when I plug 1/2 in for x. So in reality, this is saying negative 4 plus f prime of 0 multiplied by 1/2 is equal to negative 3. Well, if I were to solve this for f prime of 0, I would add the 4 over, so I'd get 1. Then I have f prime of 0 times 1/2 is equal to 1. And then I would multiply by 2 to get the f prime of 0 all by itself. When we do that, what we've just shown is that f prime of 0 is equal to 2. We showed that first derivative when I plug in 0 is equal to 2. And hopefully that kind of makes sense. The second part says it is known that f double prime of 0 equals negative 2/3 and f triple prime of 0 equals 1/3. Find the third degree Taylor polynomial of x. So again, we just take our first term, negative 4, plus we take what we found right here, that f prime of 0 equals 2, and we go 2x to the first over 1 factorial, so just 2x to the first, plus then I take my next term, negative 2/3 x squared over 2 factorial, because that's my second derivative, plus 1/3 x to the third over 3 factorial. Now that is technically our third degree Taylor polynomial. If we simplify it down, because I believe we're going to need it in the future on this problem, I get this. And you don't have to, like full credit will be given for what we have above, but that is what that simplifies down to, okay? Now it says the function h has the first derivative given by h prime of x equals f of 2x. It is known that h of 0 equals 7. Find the third degree Taylor polynomial for h about x equals 0. Now you think about this one for a second, you're like, wait a minute, h prime is equal to f of 2x. So I'm going to take my f that I found previously and just plug in, so I've got negative 4 plus, instead of x everywhere, now I'm going to have 2x. So I'm going to have plus 2 times 2x minus 1/3 times 2x squared. And then we did have one more, but you'll notice that this is the derivative. And I want to know what the original function was. So basically what I have to do is I have to say, okay, if that's the case, I'm going to take the antiderivative of this to get back to h of x. Okay, so h prime of x equals that. I need to get back to h of x. So I'm going to take the antiderivative, so I get negative 4x plus, this is 4x right now, so the antiderivative of that is 2x squared. And then this technically is negative 1/3 times 4x squared, so that's like negative 4/3 x squared. When I take the derivative, or antiderivative of that, I get negative 4/9 x to the third, okay? Now what I have to realize here is that I have an initial condition, because when I take an antiderivative, I get a plus c. So what I have to do is find out what the plus c is in this case. My plus c is when I plug in 0, all of these turn to 0, and that's equal to 7. So I get 7 is equal to 0 plus c, so c is equal to 7. So what I can say is my original polynomial is negative 4x plus 2x squared minus 4/9 x to the third plus 7, and that is our correct answer. Now there's other ways you can go about doing that. I found that that is the easiest way to do it. But there are other ways you can go about finding that. So hopefully that kind of made sense on how we were able to get that particular answer. This one had things that are a little bit different when it comes to Taylor series, in that this one basically deals with Taylor polynomials. But some of the ideas here are pretty good, and I think this is a good problem to kind of start off looking at to introduce us to what we have to do in this type of problem. Hopefully that kind of made sense. If you have any questions about this one, please let me know.